Just let us know when you're ready.
Okay. What's there? Okay, I think we're good to go.
Okay. So we have for this lesson the inference for Wunmian and sigma none and the hypothesis test. And we need to go through part 2 of the preparation assignment.
Right.
Okay, so then let's get started. And it says number 9, the graduate management admission test is used as an admission criterion in many Masters of Business Administration programs. The scores in the GMAT in the past have a mean score of 529. The BYU professor feels now that the score has improved within the last couple of years. So letter A says determine the null and alternative hypotheses.
Okay, so for the null, I got the equals 529, and then the the alternative one was it's greater than 529.
Yes.
That's what I put down.
Me too. Okay, so letter B says, suppose you got evidence that the null hypothesis should be rejected. However, in reality, the mean score of students taking the exam is still it's 529. Was a type 1 or type 2 error committed? I just wrote down the type 1 error.
That's what I got also.
Yep.
Okay, letter C says, if the analysis was done at level, I don't remember this. Does the alpha equal to 0.01 level? What is the probability of committing a type 1 error?
So that's 1 out of 100.
1 out of 100 is a 1% chance.
Yes, 1%. Okay. Letter D says, if we wanted to decrease the probability of making a type 2 error, would we need to increase or decrease the level of significance? And I just wrote down to increase the level.
Increase is what I got, yep.
So who wants to read number 10?
A study by the National Association of Realtors reported in 2004 the second home sale accounted for more than a third of residential real estate transactions. According to the report, the average age of a person buying a second home as an investment rental property was 47 years. Assuming the national standard deviation was 5, a real estate agent wants to determine if the average age of those buying investment properties in his area is different than the national average. He selects 15 of his clients who purchased an investment property and obtained the following values, which I put in my spreadsheet.
Yes, me too.
That's what I did also.
Okay. So then the question is, what is the population from which the realtor obtained his data? Well, his population was the those who were second home buyers in his area, his clients.
Yes.
He took a random sample from those clients. And research question B. So here's where I don't think like a scientist, because I don't know exactly how to write that. He's trying to figure out. My notes are basically the alternative hypothesis would be that the average age of second home buyers in his area is different than the national
average. Yes.
So
yeah. Yeah, so I wrote the data.
Go ahead.
I just wanted to say I just wrote down for the question that if the average age to purchase a second home will be different than the national average. just as you just mentioned.
Yeah. So I just put that it would not equal the 47.
Okay. So then for part B, collect the data, name at least one way the realtor could have randomly selected his samples. So I mean, you could just draw names out of a hat. You could assign everybody that's in that particular buying a second home. You could assign everybody's name and number in a spreadsheet and then use a random number generator. You could put everybody's name in a bingo cage and give it a little spin.
Yeah. Yep,
so then
lots of options.
Yeah. For describing the data, I use the Excel spreadsheet to get my histogram.
Me too.
Short paragraph, describe the data by using at least 5 descriptive statistics. I don't know exactly what to write there. I really don't. And I don't know how to write a whole paragraph about this type of research and stuff. Basically, it comes down to the observed mean was equal to 46.73 with a standard deviation of 8.227. I don't even know where to go from there. I mean, everything else is just words. I've just stated.
For this one, I just stated the 5 number summary as well. The mean, the standard deviation, as well the quartile 1, the minimum, the median, quartile 3, and the maximum.
Right.
I have a little chart.
So I wrote that down, but how do you get that? How do you word that in a paragraph? I guess that's my question. So,
yeah,
I guess get creative with your writing.
Kind of, because yes, I just came up with a chart displaying the information, but it's specifically to represent that in a paragraph.
Okay.
Now,
okay.
Yeah, I don't know a good way to write a paragraph with that.
The important thing is that your data that you reference has the mean, the standard, and then the 5 number summary, correct?
Yes.
Right.
That's what I came up with.
Okay. All right. Make inferences. So check the requirements. Since there are only 15 pieces of data, what will you need to check? Kind of drawn a blank on this one.
Yeah, so that one I thought that you'd have to check to see if the population is normally distributed.
Right. Okay, so you're checking for normal distribution, and that would be through we did that with a graph, right?
Yeah. Yeah, since the sample size was small, the 15 pieces, then you'd have to use the other, the other thing where it's parent population was normally distributed.
Right.
That's kind of what I was thinking with that one.
Okay, let me put that data in real quick here. Okay. It's fairly straight, right?
Yeah.
Okay. QQ plot. Okay. Thank you. State the goal and alternative hypothesis. Is this one or a two-tailed test? So for me, the H naught is that your mean is going to be equal to 47 years of age, and your alternative is that it does not equal 47, which would be a two-tailed.
Correct.
That's what I got.
Yeah. Yes.
So the important thing to remember about the does not equal is you're going to shade both areas to the far left and far right, correct?
Yes.
Right, yeah, the outside areas.
Okay. So test statistic, what is the formula to be used? So that's the Z, use the Z-score. And then after you write down the general formula, input the numbers you'll use, show the work, finally use Excel to calculator to compute the statistics. So inputting the mean that was found, subtracted the national average, and then divided it standard deviation by the square, which was divided by the square root of 15. We came up with negative 0.2068 rounded to 207.
Yes.
That's what I got also. Yep.
And then put that in the applicator. And found an area of 0.8360.
Yes.
Okay.
Yes.
Yep. That's what I got also.
And then whenever you compare them, you're just looking to see if the p-value that you just found was larger or smaller than your alpha, which was previously determined, correct?
Right.
All right. So with that being the case, alpha was less than my p-value, so therefore not sufficient evidence. Therefore, we reject the null. Fail to reject the null.
Yes.
That's what I got also.
Okay. And that was my statement. There's insufficient evidence that the age of the second home buyer is different than the national average.
Yeah.
Yes.
And if I was a realtor and I wanted to sell houses in my area, I would keep targeting the people in that age group.
Around that, yes. Around that mark.
That sounds right.
Okay.
Very good.
Are we ready for the quiz then?
Yes, let's go ahead and start it.
Let's do it.
All right. Here we go.
Meeting quiz.
Let's quiz this one, this one.
Yes, I did. Yes, I did.
So then it says for number 3, which hypothesis involves equality? That's the null hypothesis.
Correct.
That was the null hypothesis you said, right?
Yes.
Oh, okay. Wasn't sure if I heard that right.
Then it says the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer the next question. Remember that a p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. When computing the p-value, which hypothesis do you assume to be true?
That'd be the null hypothesis.
Correct.
Yes, it will be the null. Okay, so who wants to read number 5?
Which of the following represents the alternative hypothesis for a two-tailed test? That's going to be the non-equal, which is u does not equal 10.
Correct.
Yep, the third one down. Yeah. All right, question 6. Which of the following represents the alternative hypothesis for a left-tailed test?
It's the first option.
Yep. The
Mean is
less than 10.
The mean minus 10. Number 7 says, which of the following represents the alternative hypothesis for a right-tailed test? It's the second option. The mu greater than 10.
correct. All right. It says, remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance, or alpha. Use this information to answer the next 2 questions. Which relationship would result in failing to reject the null hypothesis? So if the p-value is greater than alpha,
Yes.
yes.
Greater, yes.
Mm-hmm.
All right, 9. Which relationship would result in rejecting the null hypothesis? So that would be the p-value is less than alpha.
Correct. So then it says an insurance company is reviewing the current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the premium is actually higher than this. It says question 10, which of the following would be the appropriate alternative hypotheses? The average claim amount will be the third option down. The average claim amount is greater than $1,500.
Greater
Right.
than, yep.
Correct.
That's what I, yep.
Which of the following would be the appropriate null hypothesis? The average claim amount is equal to 1,500, so that's the first one.
First
Yes.
option, yes. All right. The insurance company randomly selects n equals 40 claims and calculates a sample mean of 1650. Use this information to answer the next 3 questions. So the insurance company assumes the distribution of the sample mean is normal. Is this a good assumption?
Yes.
Yes, because the sample size is large.
Sample size is large.
What theorem of law justifies your answer to the previous question? The central limit theorem.
Yep.
Correct. It says number 14, which of the following is the test statistic as defined in this lesson? It's the z-score.
That's the n, right?
That's the n, or is it z?
Well, the z is a z-score, right? Is that what we're looking?
Because that's the formula we use to get the test statistic.
Right.
Because it says from the reading in my notes, it says we can use z-score to determine if the sample mean it's far from the assumed value, and this is called the test statistic, and the formula is the z-score equal to this sample mean.
The notes say in 4.2 of chapter 9, the z-score is the test statistic. X with the bar over it is the sample mean, and U is the population mean. So yes, Z would be the sample.
Okay.
Per this reading.
Perfect. Okay.
No. Then it says, go ahead. Go ahead.
All right. So
okay.
Go ahead, Carrie. I'll let you read this one.
Okay. The historical mean of sales receipts at a grocery store is $150 with standard deviation of $40. Store manager suspects that the average has decreased. She sets up the hypothesis test with the hypotheses equal 150 and less than 150. She will use a level of significance of alpha equals 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes equals $144. What is the z-score associated with this test? Round to 3 decimal places.
So
standard deviation
comes up with 144. Minus 150 Divide by 40, which is divided by the square root of, what was our sample? 36.
36.
All right.
36.
144 minus 150 should be 6. Divided by 40. Divided by. I get a z-score of negative 0.9.
Oh, I messed up somewhere.
Try it again. 144 minus 150 divided by 40, which was divided by 36. Negative 0.9 is what I got.
I'm messing up somewhere. I got negative 0.9, but I may have put something in wrong. 144.
Let's just check in. 144 minus 150. That's minus 6 divided by 40 divided 6. Yes, I got as well the negative 0.9.
Okay, that's what I got the first time.
Okay.
So negative 0.9, you said, right?
Mm-hmm. Yes, but we need to round it to 3 decimal places. Do we need to 0.900 or just?
I'll put the other zeros in. Just I don't know how much it matters, but that way it has the 3 decimal points.
Mm-hmm. Okay. So it says, what is the p-value associated with the z-score from the previous question?
I know there's a shortcut to that applet somewhere, but I.
P-value 0.930. We're getting 0.368.
That's what I got, yes.
Okay.
Says, what inference would you make about the null hypothesis for this problem? So we got 0. So this is greater than 0.05. So we fail to reject the null hypothesis.
Right, because our answer was greater than the.
Yes, because the alpha is 0.05 and we got 0.368.
Right. Okay.
Fail to reject.
Mm-hmm.
What is your conclusion for this problem? Let's see, what was she trying to find again?
So what they were trying to get is the average has decreased.
We have
So it'd be that we have insufficient evidence that the true population mean is less than 150.
Well, actually, we failed to reject the null hypothesis, which says that down it's 150.
So is that sufficient evidence that the true population is 150?
That's what I could think of. Because
I don't think it is, because in the
Mhm.
reading it was talking about, how we can't ever really prove something right. We can just
Right.
prove things not right. So I don't think we'll ever have sufficient evidence that the true population mean is 150.
Okay.
But I think we have insufficient evidence that it's less than 150. Maybe, I don't know. I could be wrong. I could be reading this
we
wrong.
have sufficient evidence that true population mean is less than.
Okay.
Let's review again this one. It says the historical mean of sales received at a grocery store is 150. Standard deviation of 40. The store manager suspects that the average has decreased. So sets up a hypothesis test with the hypotheses, the null 150, and the alternative less than 150. So the alternative fail, so we'll remain with the null. So just trying to understand the wording of the question.
Yeah.
So we have insufficient evidence that the true population mean is 150. We have sufficient evidence that the true population mean is 150. We have insufficient evidence that the true population mean is less than 150.
Well, so remember in the reading, it said that what you're trying to do is you're accepting the null as true, and you're trying to disprove it by your test, correct?
Right.
So in this test, we tried to prove with an alternative hypothesis that the mean of the spent on groceries was less than 150.
Correct.
So the data shows us that we have insufficient evidence that the true population mean is less than 150.
Right. That's how I understood it.
That's
yes.
what we just.
Yes, that sounds correct because yes, we don't have sufficient evidence. We haven't that the true population mean is less than 150. Yes, because it mentions that it is not true. I mean, there is no true hypothesis, just a null and an alternative.
Okay.
Okay, so going with the third option down.
Option 3. Okay.
Then it says number 19, there are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? This one, if not mistaken, is error 1, correct? Type 1.
Yeah,
correct.
When you reject a true null hypothesis.
If null rejected, yes, that's the error 1. Type 1.
Right.
Type 1.
Says number 20, a researcher decided that instead of using a level of significance of 0.05, he will use 0.01, which of the following will be true? Will be small. I will go with the probability of type 2 error will increase. Yes, it says whenever the alpha is small, we are committing to a type 2 error to be large, with a larger probability.
So yeah, that's the inverse theory that they were talking about. If you create your probabilities or your alpha level of significance so small that you don't ever have a type 1, they're going to decrease, and the opposite of that is that the type 2s are going to increase, correct?
Yes.
Right.
All right.
So 21 says if alpha equals to 0.05, compute the probability of committing a type 1 error.
Okay. Isn't that 5%? I don't remember.
They're probably committing a type 1 error. I'm not sure with this one.
I don't recall this one either.
Let me compute the probability of committing a type 1 error.
So is that basically saying that you have to find the z value if your observation of this is 0.05 without it?
With this one, as the previous question was, whenever we mentioned on the preparation sheet that it was at 1% probability, so is it not the same with this one as you were mentioning, Sean, having 5% probability?
So it says here in the summary,
Mhm.
at the very end, a type 1 error is committed when we reject a null hypothesis that is in reality true. A type 2 error is committed when we fail to reject a null hypothesis that is in reality not true. The value of alpha is the probability of committing a type 1 error.
Mhm.
So the value of alpha is the probability of committing a type 1 error. So that's
So
0.0.
it's the same value which it is given as 0.05 because it is based on 100%.
If that's what I just read and my brain is wrapped around it correctly, yes.
Yeah, so that's what I can think of because that's what we did whenever we mentioned. I don't remember what problem was from the preparation assignment. When we mentioned it was at 1%, when it was
Right.
given as 0.01, so it's about the same, having 0.05.
Okay. Are we ready to submit?
Let's go ahead and
It
check
was
it
just
out.
0.05, we said, right?
Mm-hmm.
Okay, that's right.
So let's check how we did with this one. This one, right, correct.
Did not like question 16. What is p-value associated with the z-score? Round to 3
Yes, me
decimal.
either. I got that one wrong. Number 16. How does the p-value associated with the z-score from the previous question?
All right, how did that go?
Let's go to the applet and type it again. Because if the z-score it's negative 0.900, it's given us the 0.368.
Right, so what I guess the question we need to look at is make sure we read the question correctly.
Right, are we figuring that out, right?
The historical mean of cells received of grocery stores with a standard deviation of 40 to store manager suspects the average has decreased. Just mentioning, because this is mentioning about decreasing, should we go just with the left side being shaded?
I don't know, I need to open the quiz back up, I guess. So we got to go through the quiz all over again. Let's get back to 17. All right, 15. Historical mean sales. So she's trying to, yes, it's less than. She's just looking for the left. So we shaded both sides, didn't we?
Mm-hmm.
Oh, so it's just supposed to be the left side?
Yes, because it's just asking for, because we're looking for something less than.
Okay. That makes sense. Let me get back in the quiz and.
Oh. Negative. All right, so go back through it again and see that. Make sure I got the answers correct.
Yeah. All right. So 3 was the null hypothesis.
Left tail test points that way, right tail test points this way.
Failing to reject null hypothesis is when the p-value is greater.
Greater than. Now, if p-value is less than, you would reject. When p is low, reject the null.
So then just for number 16, having just the left side been shaded will be 0.184.
Yeah. See, I'm still on 10.
Okay.
So they're looking for a higher one, so the average claim amount is greater than.
Greater than, yeah.
Would be the appropriate null hypothesis.
So that would be equal to the 1500
Mm-hmm.
or 12.
Size is large.
That sample size is large. It was a good assumption. This was a central limit theorem.
Mm-hmm.
Then it was Z.
Correct.
Question 15.
It's negative 0.900.
Negative 0.90. And 16 was the 0.184, right?
Correct.
Which is still larger than the alpha, so you still fail to reject.
Fail to reject.
Mm-hmm.
Insufficient evidence. The true population is less than 150. It was type 1.
Mm-hmm. Twenty is the probability of type 2 error will increase.
Type 2 error will increase.
Mm-hmm. Yes.
They're inversely related, so if one goes up, the other goes down.
Right.
Yes.
And then last one was 0.05.
All right, try this again.
Take
Submit
2.
it this time.
Yep. Remember to read the questions.
Mm-hmm.
Yes, now that's the right one for number 16.
Well, good.
Nice. Very good.
Right
Yes, I
on.
got that. This was very interesting for me.
Me too.
But we're getting there. Okay, so
Very
plan
good.
for next Tuesday then at some time.
Yeah, we should be able to go back to the normal time again. I appreciate you guys doing an hour later today. That helped out a lot.
You're fine.
No problem.
You're welcome. Okay, so then hope you have a good night then.
Perfect. Sounds good. Thank you guys.
You bet. Good night.